So in the previous video, we created the basic template for our scene and the UI. And in this video, we are going to add the functions for our game manager, which is going to include for where the player is going to move. I mean, camera is going to move, how the score is going to be updated, and all the things. So let's go inside Unity and let's start coding our game manager. So Uh, let's go inside manager and game manager, pending add. Okay. So I think these are for the GitHub adding, and what does it say? Ignored references. So what are we going to have inside our game manager? Mm, let's first delete everything, and first we are going to have a public static game manager instance, which is going to be get and private set, and inside our awake we'll set the instance to this, and after that we'll need to get a reference to the player and serialize field. This is going to be a private list of, we can have an image. So using Unity Engine.ui, and let's set as private list of image, and the first one is going to be our diamonds, and the final one is going to be our, and after that serialized field private level UI data, and let's just call it data. You can call whatever it like, but if you don't confuse it, let's call it level. And it's just going to include the number of diamonds required, so we are able to check it. Then there is going to be one more serialized field private game object, and it's going to be for our end panel and our perfect object. And finally serialized field private tm pro using tm pro tm text. We'll need to add the using tm pro. So it's going to be a tm text, and we'll call it retry text. And finally private integer for our current diamonds, and private integer for our total diamonds. And inside our awake we'll set everything up. So first thing, the current diamonds are going to be 0, and our total diamonds are going to be level UI data dot total diamonds. And after that we are going to hide our end panel, and first let's get our diamonds dot count. Diamonds of I dot set active is going to be false, and for less than total diamonds of I dot get component image, and image color is going to be black, and we need to first activate it or else it will show errors. So these are the diamonds, and let's create a method to update the diamonds. Update diamond. What will happen inside update diamond is just will first increase the current diamonds, and after that for the diamonds, for our current diamonds dot get component image, and its color will set it to white, and it's going to be before we are increased. So the current diamonds are 0, it will set the first diamond which is at index 0 to white. Now what will happen when the game ends, when it collides with our end score? So end panel is going to be shown, and after end panel is shown, let's first get our stage, and it's going to be player press dot get end constants dot data dot current stage, level, and instead of current stage we'll call it current level. So we have the current level and the stage. So let's first get the level name, and it's going, so after getting our level, let's get our score. So we can only get if it exists, so we need to check if our score exists, then we'll set it to 0. Let's also get our number of retries, so it's going to be level name plus underscore dot data dot retry. Am I recording? Yeah, I'm recording. And let's get the integer number of tries to be pair prefs dot as key for our retry key, as number of retries are 0, and we'll get it from the retry key. And finally we'll set the retry text dot text is going to be retries plus number of retries to string. And finally we'll calculate if the score is perfect, so let's first get the key, and it's going to be level name plus score and dot data dot perfect. And if our number of retries is equals to 0 and our current number of diamonds are equal to the total number of diamonds, then it's going to be perfect, and we set perfect key to 1. And after that we'll set perfect object dot set active. So we need to check if It is perfect. So we need to first get player paths dot ASCII instance dot data dot perfect. I mean, not ASCII. We just need to get it. We need to set the ASCII. Then we'll set the perfect key, else it's not going to be perfect. So this will show a perfect object, and finally we need to again show diamonds. So let's first hide all of our diamonds for int is equals to hide diamonds dot count and diamonds dot set active to false, and for less than total number of diamonds, set active to true, and I think we'll set its color to black. But instead of diamonds, we are going to use the end diamonds. And finally, for our current diamonds, so instead of I less than count, we'll use our current diamonds. There's this white. So after we have all of our diamonds, we need to update the diamonds. So they are only going to be updated if our current diamonds is greater than our current score. So where our current score is, we get for that level name. So if it is greater than that, then we'll set our level name for the current diamonds, whatever it is. So it will update our end game, and after that we need to create a function for playing the next level. So let's call it play next level, which is going to be for the next button. The first thing we are going to get is the current level and the current stage. And let's create one more function for go to main menu, and inside here unity engine dot scene management dot scene dot load sequence dot data dot main menu, and there's going to be public void restart game, and inside our restart game we'll just get the level name is going to be unity engine dot scene management dot scene manager dot get active scene, and after getting active scene we'll get its name, and then we'll set the retry key, which is going to be level name plus constants dot data dot retry, and we'll increase the we'll get the number of retries first, and it's going to be player first dot hash key for the retry key, then we'll get it, else we'll just set it to 0. We'll increase the number of retries, and we'll set the integer for the retry key to the number of retries, and after that the unity engine dot scene management dot scene manager dot load scene, and we'll load our level name scene. So this is just going to be a retry. And let's also create a function to move the camera. So public void move camera, and here we'll pass vector3 target position. And what we are going to do is private enumerator, and we'll call as I camera, which is going to get a vector3 of target pose. And here we'll pass our iMove camera for that pose. Let's get the target to be the target pose, and target.c is going to be camera.position.z. So the z position is going to be similar, and after that, while v3.distance from our target to camera.position is greater than 0.05, we'll set the camera dot position to be v3 dot move towards, and we are going to move towards from camera dot position to the target position, uh, and multiplied by camera speed multiplied by time dot delta time. And we'll need to create the camera speed, and at the end we'll set the camera dot position to be the target. And we haven't created the camera speed, so it's going to be a serialized field for the private float camera speed. Where's my camera speed? Yeah, serialized field private float camera speed. So this is going to be for the camera, 20 minutes to set up the game manager. Should be easy. Now we have set up our game manager, and what we need to do is create our obstacles and our player. Hmm, hmm, hmm. Mm, 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 So that was it for the game manager. Now we need to I forgot the play next level. So inside our play next level, we'll first check if our current level is equals to where did I go? If our current level is equals to 7, then we'll just call the go to main menu function and return. And afterwards we'll do current level plus plus, and we'll create not create yeah, dot set int constants dot data dot current level to the current level, so it doesn't mess up next time. And we'll create the level name string, and there should be somewhere where I already created it. End game level name, yeah, let's just copy it from here. And I don't think I changed to, yeah, I changed to Visual Studio. So this is going to be a level name, and what we are going to do is we'll just load the next level. So Unity Engine dot scene management dot manager dot load scene, and we'll load our level name scene, so which is going to be a next level. When we hit the what what was the end game condition when we hit the goal? So that should be it for our game manager, and let's now first create the basic template for our obstacle, and after that we'll create for our uh, all other different types of obstacles. So let's reset its transform. Game manager is also positioned correctly, and we are also going to need to create the play. So let's first add all of the scripts. So we'll attach the game manager, and it's going to be go to main menu, and inside our game manager let's lock its uh for the current diamonds we have at our levels folder, which are going to be 3, and inside our level panel score diamonds level data, we need to select and pass it, which is going to be our stages. Stage 1, the camera is going to be our camera. The camera speed, let's set it to 10 for now. The end panel is going to be our end panel, the perfect object, and finally our retry text. And next we'll start creating our layer. So for now, for the obstacle, we'll just add our items, which is going to be our platform circle to this. And let's unlock it. Attach a circle collider 2D to it so it doesn't look worse. And now, okay, I didn't. I was outside, not inside Unity. So we are inside Unity, and all I did was add all the references for all of our game managers. So this is the level data which we have created, and just all the rest of the things. So we just added a default platform with the circle collider. It's not going to be a trigger. Now let's create our player first. Hmm, hmm, hmm. So for our player, it's going to be inside our character, and let's add idle, and we'll rename it to player, and the ordering layer is going to be 1. So this is our player, and everything's 32 by 32. We'll need to rescale it afterwards, but let's save this player as a prefab inside our items folder, and we'll delete this player from this. So this is our player, as you can see. Now inside this player we are going to attach a player script, which we'll again need to create it. So let's go inside our scripts and let's create a player script. We need to set it stack to player, and before adding the player script we need to attach a box collider 2D, and let's rescale our box collider. So it doesn't look bad enough. And after that, for the material we are going to use a normal material. And why is the normal bad? Inside our player we have the normal material. Then let's create a animator, and it's going to be inside our items. We'll create an animator controller, which is going to be AC under slash player, and we'll attach our player animator controller to it. It doesn't have animations, I know it. And after having our animator controller, it will need a rigid body 2D, And similarly, we'll attach our normal to it, which is our physics material, and we'll also create a player script and attach it to the player. So let's create the animations first. So inside our animator window, let's create a file name for the an under slash player under slash idle. Let's add the sample size to maybe even less. How many do we have? So resources, character, and idle. I think we have a total of 10. So let's set it to 12. And now it is fine. So this is going to be our idle animation. So slash player under slash walk, and again this is going to be called sampled image. Why is my walk animation not working? What is already added? And finally we'll need to create one more, which is going to be our jump animation. It just has one, and we'll create a fall animation, which is again just going to have one image, and for the sample for size we'll set it to 2. Similarly for the jump we'll set it to 2, and the default animation is our idle animation. So we can have a complicated state machine, but we'll directly set it from the code. Not going to be difficult, only 10 to 20 lines. So these are the animations for our player, and let's hide that message because it fixed. And after having our animation for our player, let's create the rest of the items. So the first item we are going to create is, where's our VG? Let's create our diamond, which is just going to be an apple. So instead our prefabs and items will drop one apple to the scene. Ordering layer is going to be 1, and we'll need to resize it, but we'll just call it diamond, and we'll save it as a prefab inside our prefabs folder. Now for our tag, we'll add a tag of diamond, and its tag is going to be diamond, and we already set the ordering layer. It needs to have a circle collider 2D, which is going to be a trigger. Now similar to our diamond, we are going to have our goal, but for our goal the image is going to be our default image, and the tag is going to be finish. Now similar to goal, we are going to have our spike, but it's is going to be respawn. Let's change the image to spike. I think we should have it like, yeah, idle, and instead of always set it to sliced. Hmm. Let's just set the scale to 1 and width to be 2, height to 0.5. And I think there's a problem with the initial settings for our bike. So instead of 100, we'll set it to be 6. And it needs to be pixel perfect. So these are going to be our spikes. These are the default settings. Remove component and instead we'll attach a box collider 2D, which is going to have similar size. And again, it needs to be a trigger. We'll duplicate our spike, which is going to inside our items, and we'll create our spike ball. And this spike ball, let's go add our resource items. It is 16 by 16 pixel perfect. So again, it's going to have similar, but the image we are going to use is the spike ball image, and we'll just set it to simple and reset its transform, and similarly reset the transform so it automatically fits. So this is going to be our default spike ball. Instead of box collider, let's just have it attach with a trigger. So that is going to be our ball spike. So we created all of our spikes for our player and the items. That's now created for the default one. So let's delete this platform circle and we'll create an empty and we'll call it main. Let's reset its transform and let's save it as a prefab first. So what's going to be inside our main? So first we are going to need a circle collider 2D, which is whatever size you want, and its layer is going to be uh, where layer we are going to add a new layer. One is going to be for the gravity and the second one is going to be for the ground. Now let's add the normal material, and nah, it's not going to be no material and it's going to be set to trigger, and we are going to create a couple of scripts. So the first script is going to be gravity direction. So we are going to return the direction of the gravity on which the player is facing. So the gravity direction script is attached on the main script, and after that we are going to create a prefab variant of our circle and add our box to it or the circle to it, and we'll use that for now. So let's bring our main, where is our prefabs and our obstacles. Main inside the scene, and we'll rename this main to platform slash circle, and inside our platform slash circle we'll create not create, we'll directly attach our platform, and we'll need to change the order in layer to 1 so it's always at the front, and the transform is set up, and we'll first save it as a prefab inside our obstacles. So let's save it as a prefab variant, delete it from here, and we'll add as a prefab variant. So for the layer we'll set it to ground. No, For the layer, we'll set this to ground. And inside, we'll first need a circle collider 2D so it fits correctly. And then we'll need to add a material to it, which is going to be the normal material. Hmm. And for now, we are not going to refer to the GAT gravity direction. We'll need to. So many things to do. So where should we start first? Let's start by adding our player to the scene. So it's just that uh, scale is going to be 5, and after that we'll attach our platforms, which is going to be parented to platform. So this is how our player and platforms are going to look. Let's duplicate this 2 more times and 4, and the next one will position at. So currently there is no movement going on inside our player. So let's see how we are going to move the player. So this is the default scene and we didn't add our diamonds. So let's go inside Visual Studio and let's start coding our player first. And whatever we need, we'll code for our either the obstacles or the items. Hmm. So let's go. Where is our main menu manager? Player, yeah. There's our player. Whenever we need it, we'll open it. Yeah, we are inside our player and let's start coding our. So let's create a public int rotate value. So whenever player is going to rotate, indirectly rotate, then we'll set this rotate value. And we'll have private float for the jump force, the move force, and our gravity force. And serialize field private layer mask and ground mask and gravity mask. Hmm. Let's have serialize field. Idle, walk, jump, and finally fall. And after that we are going to have private rigid body to be RB private animate or animator or Let's just call it animator. Private sprite renderer. Why are we going to need the sprite renderer? No, let's just have it. And a private vector 3 for the gravity up direction and move direction. Private game object for the previous gravity object. And private float for the horizontal input. And private boolean for is grounded. Now inside our start method, let's first set the physics 2D dot queries it triggers to true. RB is going to be, let's remove the underscore. Get component get body 2D. Right renderer, then gravity up direction is going to be up and move direction is going to be right. And our previous gravity object is going to be game object and our rotate value is going to be 0. So hmm, hmm, hmm. So let's go inside our update loop. The first thing we are going to do is get the input. So horizontal input is going to be input dot get axis and we'll pass and after that we'll set the gravity. So the move direction is going to be v3 dot cross and we are going to cross the back multiply by the gravity up direction. So if it is pointing there, back to the gravity up direction, so it will give us the right. And float velocity y. It's going to be rb dot velocity, which is going to be v3 dot dot rb dot velocity and our gravity up direction. More direction velocity x and move direction. And after that let's get the force value which is going to be equal to gravity force. And after getting the gravity force, we'll add force inside the negative time or delta time multiplied by the force value. And finally, we'll multiply with the gravity up direction. And then we'll check if we are on the ground. So ray cast at 2D, and let's call it hit, and it's going to be physics 2D dot raycast, and we are going to raycast from transfer dot position inside the negative up direction F and on the ground mask, and is grounded is equals to hit not equal to null, not hit dot collider not equal to null. So first thing we need to do is move horizontally. So if mathf dot abs is going to be a horizontal input is greater than 0.1f, then our force value is going to be equal to move force, and we'll add force multiply by not negative time dot delta time multiplied by the horizontal input multiplied by the force value, and finally we are going to move inside our move direction. Else will apply a negative force, which is going to be velocity x, and load drag is going to be, we are on the ground, and we'll add the ground drag as the add drag, and we'll multiply the force in the negative direction. So negative drag multiplied by the force value and inside our move direction. And whenever our rotation, so if our rotate value is not equal to 0, then we'll start adding the force value is going to be our move force, and similarly we'll add the force, but instead of horizontal input we'll pass the value. Yeah, that should be. And jump. So if input dot, first thing we need to check if it is grounded, and put dot get key down, and we are going to pass the key code dot space. Then we will add rb dot add force, and jump force multiply by the gravity up direction, and it's going to be off. And finally the flipping, which is going to be the left and the right, so sr dot flip x, and it's going to be mathf dot abs of velocity x is greater than 0.02f, 0.05f. Then we'll check if velocity x is less than negative 0.05f, else we'll just set it to whatever it was. So that's going to be for the flipping. Now if it is grounded, then we'll set animator.play, and we are going to play the not grounded. It is not grounded, and our velocity y is going to be greater than I mean, we can add 0f, but let's add 0.1f. Yeah, let's have to point f. Then we'll play the jump dot name, as we are going to play the all dot name. Else if we are on the ground and our rotate value is not equal to 0 and we are on the ground, then we are going to play if velocity x is greater than 0.2f, and we'll play the walk dot name, as we'll play the idle dot name. Here instead of velocity x, we need to get the absolute value. So this is just going to play our animations, and finally we need to limit our velocity. So velocity limiter, and inside our velocity limiter, first we need to check if method.abs of velocity y is greater than gravity force multiplied by time dot delta time multiplied by 4f. Then force value is equals to velocity y, and we'll add a force inside the negative velocity y direction, and which is going to be our force value multiplied by the gravity of direction. And similarly, let's copy this line of code again. Why it is grassity. Now how to change? I mean, there should be some shortcut, but I don't remember. But here we are not using the gravity. Here we are using the force, and here we'll use velocity x. Then force value is going to be velocity x, and we'll use rb dot add force. Already an r. Still not enough. So we are going to add the force, and where we need to add the force inside the negative velocity y multiplied by move direction, which is going to be the negative force value multiplied by the move direction. So it will just limit our velocity. And finally, inside our fixed update, we need to set its transform position. So let's set quaternion rotation, and it's going to be quaternion dot from to rotation, and we are going to go from transform dot up to gravity up direction, and we'll multiply it by transform dot rotation, and we'll set the transform dot rotation to be quaternion dot slurp from transform dot rotation to rotation from time dot delta time multiplied by NF. So it will set up a rotation. And finally, let's set our on trigger enter 2D. And on trigger enter 2D, first we'll check if collision dot compile tag. And first we will check for our diamond, and we'll call the game manager instance dot update diamond, and we'll destroy the collision dot game object. So it's going to update our diamond. If you want have any animations, you can also create it. Now after that, if collision dot compare tag instance dot data dot what we need to check depth instance dot tags dot depth, and we'll call the game manager dot instance dot again, and we'll return. And similarly, if collision dot compare tag constants dot tags dot win, and we'll call game manager dot instance dot I think this one is going to be the end game, and previous one is going to be the restart game. And we'll call the destroy game object function. I mean, it doesn't matter, but let's just call it. So that was just a code for the player, and after that we are going to need one more function, which is going to be public void get gravity direction. Now we are going to set this up in the next, I mean, when we create the obstacles, but for now what we'll do is we'll set the gravity of direction to be transform dot position dot normalized. That should be fine, and all it does is just set the transform dot position. And let's see how our player moves right now. So we have all of our three platforms, and let's get inside our items, and let's go inside our players, and let's first add our ground mask, which is going to be our ground, and our gravity mask, which is going to be the gravity. And for the animation clips, serialized object no reference, I don't know. This is going to be the fall animation, the idle animation, the jump animation, and the walk animation. And let's set the ground at to true, add drag to 1, gravity force to 12, jump force to 1000, move force to 800. And let's hit play and let's see how our player is doing. Hmm. 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 So where did our player go? I think it should be, yeah, it's too far. Serialized object of serialized property has been disposed. I don't know what it is. So the forces are too much. Previous game object. So it's not showing any errors, but it's falling down because that's the gravity direction. And hmm, instead of uh, where it is animator, if we are not on the ground, it's going to be a problem. It is tagged as ground, so it is showing the falling animation. If we are on the ground, walk and idle, jump and fall. We need to call the get gravity direction before setting the move force. So call the get gravity direction first. And let's see how our player plays the game. So let's hit play. And currently, uh, player is falling and it is moving itself. Ground mask and gravity mask. So it should not happen, but rigid body, automatic. Yeah, that's the problem with the gravity scale. So let's go inside our build settings or our project settings, and we need to find our physics 2D and set the gravity to 0. So as you can see, we go inside physics settings and set gravity to 0. So now if we hit play, we should be able to see it working. So as you can see, it's too slow, and I think our exposition is not much, but don't know. We'll see how it's going. So it's playing the fall animation, and it moved too far. Gravity force higher, and that's first. Okay, so the jump force needs to be. Where is our player? So in our player, the jump force needs to be 12 and our gravity force needs to be 1000. Now let's go inside the scene and let's hit play. And we should be able to see our player moving. So there is a problem. Hmm. So as you can see, we are able to move the player, but there are some problems with the animation. And currently it's looking good right now, but we are adding force in the update. We are not able to, it will be choppy when we are playing it on a device. So what we change inside the player, we need to change some values for our animator. So if we are not on the ground, then hmm, now it looks good. Now if we are on the ground and rotate value needs to be equal to 0, then only we are going to play the animation. So now it should work fine, and that was for our player. So let's hit play, and the first thing we should be able to see is our idle animation, and our walk animation is also working. We are able to jump, and oh, what changed it to, so if we are moving left, we are able to move left. The jump force is also correct. I think we'll need to change the gravity force a little bit. So let's change the gravity force, gravity of direction, time dot delta time, horizontal input, force value. What should we change the gravity force to? Let's make it 2000. Let's see how it works. So again, it's going to be similar and choppy, but that was our basic player moment, and currently we are only able to move on this only, and our rotate value is a little bit slower. Uh, that was it. So that was the player movement, and we set up the animations, the jump force, and the next video will set up the all the obstacles and items we already set up. So as soon as we finish our first obstacle, our first level should be ready to go. And if you guys watched till now, thank you guys for watching, and see you guys in the next video.